Today, we're actually going to talk about two quadrilaterals. The first one I want to talk about is the rhombus. The rhombus is a parallelogram with four congruent sides. So that's going to be our first property that we want to discuss, is that rhombi have four congruent sides. So if I was to label that, all four of these, not just opposite sides are congruent, but all four are going to be the same length. The second property that rhombi have is that their diagonals are perpendicular. And so, if y'all remember the definition of perpendicular, that means they form 90-degree angles. So let's draw our diagonals, and remember they go from one corner to the other. Where my diagonals intersect is where they form right angles. So here would be a right angle, here would be a right angle, here, and here. The third property that rhombi hold is that their diagonals bisect the angles, the corner angles. And so here, that means that this angle, and I'm going to draw a heart here, is congruent to this angle, and this angle is congruent to this angle, and then here, I'll draw circles here. This angle and this angle is congruent, and this angle and this angle is congruent. They also have all properties of a parallelogram, which means a rhombus fits in the parallelogram category. Now, if I wanted to solve problems using the properties of a parallelogram, if I was going to be using the sides, we would use the fact that all sides are equal. So that means you set sides equal. If I was going to solve for the angles, there's a couple things we can do here. First, our middle angles form 90-degree angles. So all of these right here form 90 degree. The second corner angles are bisected. So two things apply here. One, we have part equals part, and two, we have 2 times part equals the whole. Another thing that they give us is that, or that we can use, is that our opposite angles are equal. And the last thing is that our consecutive angles add to 180. So these two come along with the properties of the parallelogram, and then we got the first two from the fact that our diagonals are perpendicular and that our diagonals bisect our angles. And then if we were solving using diagonals, our diagonals actually form, the first one, let me fix this, they form right triangles due to the right angle here. So that means that a squared plus b squared equals c squared would apply. And then the second thing is that our diagonals bisect each other, So again, we have that part equals part, and 2 times our part equals the whole. And then squares go along with rhombi because when we're looking at their properties, well, first, the definition of a square is a parallelogram with 4 right angles and 4 congruent sides. So a parallelogram with 4 right angles is what we said was a rectangle. And then 4 congruent sides is what we said was a rhombus. So it has the properties of a rectangle and a rhombus and a parallelogram. So that means that all my sides are equal. It means that my diagonals, when drawn, form 90-degree angles and they bisect each other. So I would have 90-degree angles at all of these. I would know that these are bisected, so this would equal this, would equal this, would equal this. And also we learned with rhombi that the corners are being bisected, so not only are these right angles because of the definition of a square, but if 90 degrees is being bisected, that means that this piece is 45 degrees and this piece is 45 degrees, and it works that same way all the way around. This piece is, or this angle is 45 degrees, this angle is 45 degrees. So squares are nice and easy. If we're solving for sides, again, we know that all 4 sides are congruent, so we would use all sides are equal. If we were solving for angles, we have that our corner angles equal 90 degrees. We have that our corner angles are bisected. So that means that each piece is 45 degrees. And then we also know that our middle angles equal 90 as well. So if we were going to solve for diagonals, it would be the same as the rhombus as well. So our diagonals are equal, and then our diagonals also bisect, which means 2 things. That part equals part, and 2 times our part equals the whole.